What's going on, everybody? Johnny Bannon here at Trepa Technologies, and today we're going to finish up Domain 1, our evolving modern network environment. So, new-ish technologies, a lot of this stuff has been around for like the past 5, 6, 7 years in the year 2024, but we're going to go over it. This is the last section of Domain 1, and again, this is high-level overview. I don't think anybody who's just Network Plus certified with less than a year experience looking to get their first junior network administrator job expects you to have a full understanding or in-depth understanding of these technologies. So let's go ahead and get started. Let's look at what we're going to learn today. So we are going to go over these objectives here. So let me move my face out of the way just a little bit. So we are going to go over secure access, secure edge, SASE, and SSE, which is just, it's SASE without the networking piece. Then we're going to go over infrastructure as code. Now, as much as I would love to create a Git repo with you guys, put some basic Python code in there, maybe some HTML, CSS code generated from ChatGPT, download it, make a change, make a new branch, do a pull request. We're not going to do that in this video. What I'm just going to explain to you is what source control is and how it can help you as a network administrator. And this kind of ties into technologies like Python, like Ansible, like Terraform that allow you to look at your network. Well, we'll get into it. High level, okay? I'm not going to teach you how to do coding here. And then we're going to talk IPv6. Quick overview, how IPv6 is laid out, how it gets rid of our deprecation issue or exhaustion issue, to be more accurate, with IP addressing, IPv4 addressing. And they're going to talk about compatibility. So how we can make IPv4 work with IPv6 and the different compatibility technologies or techniques we have at the WAN side or just in our networks. Okay, so first, we're going to talk about SASE and SSE. This stands for Secure Access, Secure Edge, or Security Service Edge. So this can be a single piece of hardware, single piece of software, but this is just a modern architecture, is more accurate, more like a framework, more like a strategy to have 4 basics under a single umbrella. So SASE, Secure Access, Secure Edge, was introduced because of our traditional networks not being so traditional anymore. So in a traditional network environment, we had an easy to define perimeter. And what we mean by that is we were siloed. If I needed to go into the enterprise, and I went over this in our last video, to do work, maybe we had a VPN that allowed us to get into our corporate network, and then we did our work there. And that was as hybrid of a model as we got. To do work on your intranet and your corporate network and your enterprise, you had to be in the office. And all your enterprise resources and networks and systems were all right there. And there was a clear perimeter set by like a firewall or a router that said the outside untrusted networks to the ISP, inside we have our network. And then we started, having hub and spoke topologies where we had spoke offices that created VPNs into our data center or HQ office. That, again, granted those users access from the other side of the world or the other side of the country to the corporate network. But then the cloud became a thing. Applications not hosted on our enterprise, on our local data centers became a thing. Remote working became a thing where you had to maybe access Office 365 or a SaaS application in a cloud environment that the company, quote unquote, owned, as in rented and leased from the cloud data center, but a resource we paid for. And we now had a new threat vector. So we started to come up with technologies that said, okay, well, one, we have all these different dual-homed ISP connections, WAN connections from remote workers, from all of our spokes, and we're paying a lot for dedicated circuits and MPLS. Let's introduce SD-WAN, a software-defined wide area network, and let's introduce that fabric. So we started doing SD-WAN. But then we still had our users, and we said, okay, well, they're accessing things in the cloud, they're accessing our SaaS applications, they're accessing the internet, and they're accessing our corporate network all from a single device. So how do we take that single device and have, how do we look inside of it? How do we monitor that? Well, we have things like secure web gateways. We have things like CASB, cloud access security brokers, that are able to monitor the connections from our remote users or from our local users on-prem to those cloud applications and resources. And then we said, okay, well, we still need to have some firewall tools. So we had firewall as a service. And then we said, hey, Well, we have that single user accessing all these different corporate-owned resources that are not completely under our single umbrella anymore in-house. So we want to define zero trust network access. Well, maybe we create secure TLS tunnels to everything, or secure tunnels from inside our corporate network to our corporate network to our cloud applications. And we had all these different vendors that we would try to make this work with in a very complex ecosystem. We had different cloud vendors we went with that hosted resources. So how did we do all these protections that we wanted without getting so much tech debt, without being like, oh my goodness, we have so much IT, we only have so much IT budget, we can't afford to have experts in all these different tools and technologies to protect our very hybrid, very dynamic environments. So Sassy. So then vendors came up with Sassy, or the Sassy architecture, where we combine secure web gateways, cloud access security brokers, firewall as a service, and zero trust network access under a single umbrella, maybe a single pane of glass technology or tool, like Cisco Sassy here, combining the Cisco umbrella, Cisco Duo, and SD-WAN, saying, okay, we can do all that for you, and we're going to call it Cisco Sassy. And that's what it was. It was just a way for us to get all those protections and not burden ourselves with trying to learn all these different tools and technologies. We can say, hey, we're doing secure access service, secure edge, with these tools. Now, SSE, it does the same thing minus the network part. So SSE just provides us the security. It doesn't include the SD-WAN. So let's go over these bullet points here just to make sure we hit everything. So unified security and networking. So Sassy and SSE provide a unified framework for managing both networking and security. Scalability. SSE, again, minus the networking portion, okay? Scalability. So by leveraging cloud-native architecture, Sassy and SSE can scale up or down to meet the needs of dynamic workloads. And what we're saying is we can deploy the Sassy or SSE environment, or payload in a cloud, and then leverage that cloud scalability. Improve performance. So Sassy utilizes SD-WAN to optimize routing traffic on real-time conditions, what we learned about in our previous section. And then that zero trust security. So we get that zero trust network access, a zero trust architecture for our network. So it implements a zero trust model. Okay, so now moving on. Now we're going to talk about infrastructure as code, where I almost kind of dived too deep into in that intro. So traditional networking. The way we did traditional networking is we had a Visio diagram up in our NOC. We had SolarWinds, and we would SSH, right? And I say that's the technologies I use, but it could have been any SNMP software that does monitoring. We looked at our entire infrastructure, and if a user called their help desk with some network issues, their phone was going up and down, it wasn't the cable, so we had to go in and look at our switch. We'd have to SSH to that router, do like an mtrace, like a MAC address trace, or through our CLI, go find where that port was and see what's wrong with that port that connected to that phone. Small example. If we wanted to deploy new switches, we'd have to bring them into the NOC, console in, configure them completely, drive down, rack that switch, and then we did that one by one by one. Well, infrastructure as code is a different way to look at our network. Now, infrastructure as code works in a cloud environment, works in a DevOps environment, in a systems environment, but this is the Network Plus exam, so I'm going to talk about it from a network environment. What infrastructure as code allows us to do is look at our network not as individual pieces that we have to go individually configure when we had to make a change or an update or do some troubleshooting, but looks as our whole network as a single piece of code that we can then automate, that we can then run playbooks against, that we can, again, automate tasks that we may do on individual devices at scale. So infrastructure as code allows us to look at our network and have some key components, have source control like GitHub, have IPAM, something like NatoBot, an IP address management system, and then technologies like Ansible or Python or Terraform or Puppet that'll allow us to create playbooks or scripts to automate things on our network. And the great thing about this is if we have a multi-vendor environment, Ansible, Python, Terraform, Puppet, they allow us to automate these different network vendors. So I can have a Palo Alto firewall. I can have an IaC firewall. I can have Cisco, Juniper, and HP switches, and I can create VLANs all under one playbook, Ansible playbook. So that's what infrastructure as code allows us to do. As you can see on the screen here, I have a drawing of a typical pipeline when we're doing IaC. Now let's say, our developers are creating a web application. Our DevOps team and the IT operations team is providing that platform. So we're integrated into their development pipeline to, at scale, deploy the application they're delivering to us. And we do that through the use of our scripting technologies, like Terraform. If we're in the cloud, that's a huge thing, right? Multi-vendor cloud environment, you can use Terraform. Ansible and Python if we need to quickly spin up network resources, right? So again, let's go over these bullet points to make sure we don't miss anything. So playbooks, templates, reusable tasks. Playbooks and templates are predefined sets of configurations and tasks that can be reused across multiple deployments. Creating VLANs, right? It's always when you learn like network automation, it's always like the easiest one. Like, oh, let's make a for loop that iterates through VLANs 1 through 20 in Python and go deploy, configure those VLANs in an Arista and a Cisco and a Juniper switch. Okay, another benefit of infrastructure as code is centralized upgrades. So we can upgrade all of our devices at once. So a good example, a Terraform script might automate the upgrade of a virtual machine across multiple cloud environments. Now on the network, we could do the same thing with Ansible or Terraform and says, hey, we want to make a change, an update to, the baseline configuration. Hey, we got to change a security STIG or security requirement came out, and we have to make sure that the native VLAN on all of our access switches and distro switches, or our spine and leaf switches, whatever our environment is VLAN 10 now. Our native VLAN is VLAN 10. Okay, sweet. So we go ahead and do that with a single Ansible playbook. We create an inventory that says, here's all the host names, the IP addresses, and the login info. And maybe we save that login info in a secure vault. That's part of our pipeline. And now we run a single Ansible playbook to update all the native VLANs. Dynamic inventories. So this is something where we have a dynamic state. So I've personally done this in an environment where, let's say, we're adding switches, okay? So instead of adding those switch host names, IP addresses, and the credentials in the Ansible playbook itself, we have a playbook that goes and reaches out to, let's say, an IPAM solution. So let's say I have NanoBot. So in NanoBot, I put in these new switches that are going to go on the network. And I put in the host names, their management IPs, and their either local credentials or their TACX credentials. And maybe that's a service account that doesn't change. And before I run a playbook to update the native VLANs on all the switches, instead of having an old inventory from a year ago that I might have to manually update, I may have forgot to add the newer switches in our environment, the inventory is updated with another task that says, hey, before you run this playbook that's going to update the native VLANs, go get a new inventory. Make sure your inventory is up to date. So we run a task that goes and updates our inventory, pulls in all the current switches and network devices in our IPAM, and then run that task to update the native VLAN against that current inventory. So that's what a dynamic inventory is in infrastructure as code. Okay, now source control. So we went over infrastructure as code. One of the key components of that is having a source control mechanism. And that's always Git, right? It's Git. You guys may have seen it. You guys watching. If you've never used Git locally, that's originally what it was for. Just a source control management that came with Linux. It was invented, not for Linux, by the people that invented Linux. And then we have the web application GitHub that I'm sure any CS student, I think freshman year, you get a GitHub account, right? And what that really is a way for us to do source control management when we do iterative changes to our code. So let's say we deploy a web application, okay? So we have our main source code, and we call that the master branch, the main branch, whatever you want to call it, the production branch. Now that branch is going to have all of our code, and we'll manage this code locally, we'll test maybe locally, and then we push to GitHub, and that's where we store it. And so our local source, our local code that we make, we always got to push to our source control manager in GitHub. And now we start having a team. So I created this app, I got my seed round funding from a venture capitalist, and now I got a whole team I got to manage. So I add a few junior devs, a front end, a back end dev, and now we have devs touching my source code. So what do? So what you do is you create development branches. You create a development branch, let that junior dev, that front end, that back end dev make their changes, and then they submit those changes in what's called a pull request. Then you as the senior, you go through, you look at their change, and what you're really looking at is your master branch and their dev or test branch. Say, okay, what did they add? What's the differences between these two branches? How does this work within the code? Okay, this is good. I'm going to approve. I'm going to merge that test branch into the master branch. That's our feature update, right? That's our new feature. And then maybe I delete that dev branch. Or maybe I keep it just for, maybe my life cycle is keep that dev branch for 30 to 60 days. Whatever the case may be. That's source control. So we have a central repository that we make changes against. Okay, and now, emerging technologies. IPv6 has been around forever. It's a part of this section. Talk to CompTIA about it. What I'm going to want to go over is just the basics of IPv6. So IPv6 is formatted in what's called hexadecimal. That's 0 through 9. That's A through F. It's the same thing that your MAC addresses are formatted in. So this IPv6 is 128 bits, and it's formatted in hexadecimal. All right? Now, there's going to be 8 what's called hextets that have 4 hexadecimal digits in each hextet. They're going to be separated by a colon. Now, you can see we still have a network ID and a host portion, a network portion, and a host portion. But you can see our prefixes are a little different. So instead of like a classic /24, what you see a lot is a /64, which means 2 to the 64 power is how many unique IPv6 addresses you can have in our example down here. So that leaves us a lot of room, right? IPv6 also has different types of addressing. So they're going to have what's called global unicast, link local, EUI64 format for our global unicast. We have unique local. They're going to have multicast addressing. And all these different types are going to be defined by their first hextet. So if you look at this chart right here, you can see this first hextet. So if I put a line under here, this is a global unicast, which is very similar. Well, it's the same thing as a public IP, essentially, IPv4. If I assign a workstation with that 2001 and that's the first hextet, that means my computer is actually reachable from the internet. Now, this is like in a basic network where we don't have firewalls and whatever, right? That's a global unicast. This FE80 is known as a link local address, something that's automatically created, and it's only within your LAN, only within your Ethernet segment. So this FE80 link locals, they're similar to private IPs and IPv4, not exactly a one-for-one, they're not synonymous, but they're just for within your Ethernet segment, for your LAN. This FF02, that's our multicast range. So you have these different types of IPv6 addresses. IPv6 doesn't do broadcast, so there's no broadcast address. It does unicast, multicast, and anycast. Okay, so let's move on. So what we really are talking about here, because again, IPv6 is not an emerging technology, it's not anything new, is just how we get compatibility with our IPv4 networks. So we have a few technologies. So tunneling. So tunneling allows IPv6 packets to be encapsulated within an IPv4 packet. So this is like, okay, we have IPv6 here, and we have an IPv6 network over here. But our WAN, let's forget this is here, is only IPv4. So we can tunnel. So we're going to encapsulate an IPv6 packet inside an IPv4 packet. That looks really bad, IPv4, and allow it to cross the WAN, okay? Till it gets to like an IPv6 compatible network. We have dual stack. So that's what I have drawn up here. Well, at the WAN side, it can do both. So each router, let's say this is R1, this is R2, is compatible with both. It can do both. We have NAT64, NAT64. This is a translation mechanism that allows IPv6 only devices to communicate with IPv4 only devices. So this is done by translating IPv6 addresses into IPv4 and vice versa. This is just NAT, another form of network address translation that says, hey, if you're IPv4 only, we only do IPv6, and you got to talk down here, we can translate you into an IPv6 address, okay? And we'll have that NAT table that says when they respond back to this IPv6 address, will send back to your IPv4 address. So just another NAT technology that does it for IPv6, IPv4, or vice versa, IPv4 to IPv6. All right, now let's do our quiz. Okay, so now we're going to take our domain 1.8.2 quiz. Let's go ahead. I've already done it before, but we're going to try again, see what we get. Okay, so question 1. What is the main advantage of using version control in the context of infrastructure as code? So we're going to go with D here. It helps in keeping track of changes and rolling back problematic updates. So that's what version control is. I don't know if I touched on that too much, but yeah, when we update, we do a major or a minor feature update to our application, our operating system, we do version control. And the way version control is typically expressed, let me move my pen out of the way here, is let's say we have 1.2.3.beta. Beta is only if it actually is beta. We don't need to have that here. This would be the major change, or the major feature, major update, right? This would be the minor. And this would be like a patch, okay? Patch. My handwriting is atrocious here. Let me erase this and start over. So 1.2.3 is our version, right? This is the major. This is the minor. And this is a patch. And then, of course, if we want, this is optional. So I'm going to write OPT. We can put beta if this is like a beta app or whatever the case may be. Okay, so that is question 1. Now let's move on. Question 2. Which of the following strategies is used to ensure compatibility between IPv4 and IPv6 networks? Well, dual stack. The only thing on there relating to this question is dual stack. Everything else is unrelated. Question 3. Which of the following best describes infrastructure as code? IaC. Hardware, physical hardware, no. Manually configuring, of course not. We're going to go with C here. A practice that uses code to automate the management and provisioning of infrastructure. Question 4. What is the primary purpose of Secure Access Service Edge? It's going to be to unify network security and wide area networking in a single cloud delivered service. So remember, that's what Sassy does, SASE. SSE, Secure Service Edge, does everything Sassy does minus the SD-WAN, okay? Question 5. What is configuration drift and how does infrastructure as code help prevent it? I think it's going to be A here. Could be B too. Configuration drift refers to the divergence of infrastructure from its intended state. IaC helps prevent it by automating compliance with predefined configurations. Let's see. C here. Configuration drift refers to network latency. That's not it. Outdated hardware. That's not it. So we're stuck between A and B. So I'm going to go with A here. Actually, let's reread this. Configuration drift refers to the changes in software versions over time. I'm actually going to go with B here. Configuration drift refers to the divergence of infrastructure from its intended state. IaC helps prevent it by automating compliance with predefined configurations. So yeah, it's not really talking about software versioning, because your version control is something that's always something you have, right? You know what the major and minor is. This is like talking about infrastructure. This is infrastructure as code is talking about our Network Plus exam, right? Could be your cloud infrastructure, your system, your servers, our network infrastructure, okay? If our intended state is to have the native VLAN be 10 for all of our switches, core, distro, access, spine, leaf switches, then IaC can help us make sure that that's happening, right? Configuration drift is when like a junior admin puts up a switch real quick. We had a uplift of employees come and they just forgot to do that, but the switch is working, so whatever, who cares? They got access to the network, right? IaC helps prevent that kind of thing from happening. All right, so there we go. All right, question 6. Which of the following is a key benefit of using Secure Access Service Edge? It doesn't replace, not data storage at all, nothing to do with encryption. It can help that, but because you TLS tunnels, right, with our zero trust network access. But okay, yeah, it's going to be B. It centralizes network security and improves access performance by leveraging cloud native architecture. Awesome. So we got 100%. I want to thank you all for viewing. Do not forget to like and subscribe. Hit that bell. Tell your friends. And for all my military guys out there watching, guys and girls, click the link below to see how you can get all of our training for free with the Army Cool program. So active duty Army, Reserve, or National Guard. Thank you and stay tuned because now we're done with Domain 1 and we're moving on to Domain 2.